All right, everybody, let's get this started. Welcome. My name is Neil DeMazier. I'm the Vice President of Sales and Marketing here at Imagine, and you are tuned into Quarantine Sessions number 11. We're doing something a little different for this one. This one is actually not focused on anything dental whatsoever, but we really wanted to take a moment and an opportunity to give everybody a great set of tools and techniques and methods to design and fabricate your own custom respirator that you can use, that you can reuse, keep yourself safe, print some up for your loved ones or your colleagues or your employees, or just to donate, and everybody kind of do their part to keep everybody else safe. So that's what we're going to be focused on today. We've got a lot of really cool stuff to cover. One thing that I just want to mention, we will be taking your questions throughout the course of this presentation today. So please be sure to submit those via the chat function towards the bottom of the screen there. All you got to do is click on that, send us through a question. I'll be keeping an eye on it throughout the course of the webinar. So if you pose a question, we'll be sure to get it answered. So feel free to send those through as they occur to you. We love having these be a great sort of interactive experience. And second, if you want to get all this information again after the fact, we're going to be posting this both to our website as well as our YouTube channel. So keep an eye out for them on that. YouTube channel posts all of our Imagine Academy quarantine sessions, which, like I mentioned, this is number 11. So there's a lot of great content already in there on Roland products, on NextDent products, on a bunch of ExoCAD stuff. So a lot of great stuff to check out. So be sure to join us over there on YouTube at Imagine USA. But with all that said, without any further ado, I want to introduce my two guests today. These are colleagues of mine. Josh Townsend is the Chief Technology Officer for Imagine, and then Daniel Choi is one of our senior engineers, definitely our most senior engineer. And they're going to be talking to us today all about the R&D that they've done, the process they've developed, and the steps that they've kind of fine-tuned to produce a really great, well-refined custom respirator mask. So without any further ado, Josh, why don't you go ahead? I'm gonna let you take the reins here, and why don't you maybe just start by telling us all about how this design came about, you know, how you kind of refined it and what you did to sort of bring it to where it's at today.
All right, sounds good. Did you want to pass over the video baton over to me?
Yeah, you should be able to take the video baton right now.
Okay, perfect.
There you go.
Thank you for the introduction, Neil. I wanted to, start off by saying it's just amazing how quickly our industry has shifted in order to answer to the calling for help. We at Imagine, we've also refocused part of our business to answer to this calling and to offer a software solution and the know-how in order to design a good face mask that's functional too at the same time. Now, keep in mind that we are not by far medical professionals here or healthcare professionals. We've done our research, we've done our due diligence with testing as well too, to come up with a good solution that we could offer. Now, those three main criteria when coming up with a software solution and an offering for a good face mask design. First is breathability without condensation. Next is comfort and fit. And finally, ease of design. So basically at this point, I can kind of show you the history of our designs itself. So this is actually one of our very first designs. We have a more aesthetic appeal for the shape of the mask itself. We utilized a cap attachment that was available over the internet. Now, one of the concepts was the fact that we wanted to offer different cap attachments for different filters that were available in the market. So that was my very first face mask design. Now, if you look here, basically we have a different filter attachment. And what this would offer is an attachment for one of these P100 filters. There's actually two different connections for that P100 filter. There's a screw-on style, and there's also a bayonet connection as well too. We also offered a cap attachment for one of these Roomba filters here. But what it came down to was really availability for these filters. And what we noticed was that it was not so easily accessible for us to get our hands on these filters. So we kind of omitted those ideas. So we moved on to our next concept, which was, all right, well, let's keep that same face mask design and provide a cap attachment where basically you can cut out your own filters and just utilize it as part of the mask. Now, the only issue with this face mask design itself was because of the smaller diameter opening here, breathability was almost non-existent. I kept this face mask on for about 10 minutes. I thought I was going to pass out. So what also happened during that period of time was the fact that when I was exhaling, there was actually a lot of pressure buildup and a lot of heat within the mask to the point where I was forming a lot of water droplets. And as you may know, if you start forming water droplets on the filter becomes almost useless at that point. So we went on to the next concept, which was incorporating a larger cap design. And basically with this actually offered a lot more breathability. I could exhale properly, and there was no condensation buildup. Now, going back to one of my initial designs here, this logo you can see is actually a cap. And what we wanted to offer at that time was something called an exhale valve. So you could breathe in, and then when you're breathing out, it'll actually breathe out through this valve here. But through some research and whatnot, we were able to find that you're able to protect yourself perfectly fine from others. But if you are a carrier of the virus itself, it was actually a great exit point for the virus to reach others. So that was the reason for omitting the whole design of the exhale valve. Now, finally, we came on to our final design of the mask. What it came down to was the fact that simplicity was key. We didn't need it to look so aesthetic too at the same time. It just needed to be functional, right? So I actually printed this out on my hobby printer out of a silk gold PLA. And this is just more for aesthetic appeal. But you can see that it offers a larger opening. So, you know, you could breathe properly and exhale properly. There's been a lot of testing with software solutions as well too. I guess first off, because we are in the dental industry, we wanted to try to see if we could actually utilize exocad. That didn't work out so well. So we moved on to Mesh Mixer, which is commonly used in our industry today as well too. It offered everything that we needed, but the workflow wasn't perfect. So from the 3 criteria that I listed off earlier, it didn't check off the box of ease of design. Yes, definitely, you can utilize Mesh Mixer. It's a great tool to utilize in order to come up with your final custom face mask design. But again, was it easy for everybody? And the answer was no at that point. Now, do keep in mind that there are some people out there that actually graciously created plugins for these software. So there's one for Mesh Mixer, and the one that we ended up going with to customize even further was a software called Blender. Now with Blender, there's a person that actually created a plugin. I can't remember his name, but he offered a plugin that we kind of tore apart, deconstructed, and was able to customize according to our needs and to make sure that it checked off all the boxes for our criteria. So Daniel here shortly will be going over that process as well too. And what it comes down to is that you'll be able to come up with a custom face mask design in about 2 to 3 minutes. So it's going to be a very short demonstration. Now, one of the first components of coming up with a custom face mask design is acquiring a good face scan. Now, we've tested out a few different scanners in the market. First one is the Artec Spider. And I do want to give a shout out to Fernando Polanco. He graciously lent us his Artec Spider to kind of aid us in testing out face scans, you know, for this whole process. Now, if you have never heard of the Artec Spider, it's actually a industrial handheld scanner, which you could really use to scan anything you want. Fernando actually refitted it to be applicable for the dental industry. So again, shout out to Fernando. The next scanner that we actually tested was something called a DOF Snap. It offered a great resolution for the scanning. It worked. And basically, finally, we went with a Bellus 3D application. Now, the demonstration I'm going to be providing today is going to be based off the Bellus 3D app. And the reason for this is because, well, first, you can download it directly onto your cell phone. It's a cell phone application. And next, you could scan yourself literally anywhere. You can scan it from the comforts of your own home, in the bathroom, really anywhere. And it's a highly intuitive software. So it literally gives you instructions of how to proceed with scanning your face with ease. So to start off with a demonstration, I'm going to show you the application here. Hope everybody can see. It's called the Bellus 3D app.
And one thing that I want to point out just as you're getting this going here, Josh, is accessibility was a really big thing for us when crafting this workflow, right? So
that's right. Whether it came to filters,
our tech Spider works great, but it's an expensive piece of equipment. DOF Snap face scanner. We have many customers using those, and they work flawlessly. But again, it's an expensive piece of equipment. The Bellus app is what, like $2, I think.
Basically, after you download the application, for every scan that you want to export, it's 99 cents.
There you go. So it's really, really accessible. And similar thing with the Blender software that Daniel's going to be showing us in just a moment. If I'm correct, that's freeware, basically. There's no charge for that software.
There is no charge whatsoever.
Yeah, so really, really accessible workflow that anybody can do for next to no cost.
Yep, exactly.
And even, I mean, gosh, even the mask that you showed earlier, the gold one that you printed at home, I mean, that was printed on your printer, which was what, a $200 printer? Like, it's not an expensive printer.
Yeah, it was about I got it on Black Friday, got it for about $175.
There you go. Right. So I guess the only reason I jump in and mention it is that, we're going to show you some really cool stuff today, everybody, but like, you don't need a lot of money to do this. A lot of it can be done free. Other parts can be done for next to nothing. And, even if you don't have a printer, you can purchase one for not too much money. Or, if you need to be connected with somebody that might have 3D printing resources, reach out to us after the webinar today, and we'll be able to connect you with somebody.
Thank you, Neil. All right, so let's go ahead and proceed with the demonstration of the actual face scan itself. So after I open up the application, you'll be able to see this on screen. So there's three major options in order to acquire a face scan. So the first here, this is going to be just for a straight face. Next is going to be the face and the neck. And there's also an option to do a full head face scan. So basically what I've noticed is that when you use the first option just for the face, this actually captures everything that you need, meaning the chin, the cheeks, and just the front of the face in general. So you may be able to overhear my phone as it provides instructions, but let me go ahead and take a quick demonstration of this.
Look at the camera. Turn left. Turn to the middle. Turn to the middle. Capture completed.
Wow, that was quick.
Yeah, very quick.
And one thing real quick is that you don't need a phone with a 3D camera to use this, right? Like, I know like the iPhone X has a 3D camera. Look at that. That's amazing.
Yeah, it captured all the main criteria for a good face scan, which is the chin, the cheeks, and the front of the face.
That looks great. And again, just regular 2D camera works fine, right?
Yep, exactly. Yeah. So again, once you take a good face scan, basically all you want to do afterwards, there's going to be an option to export the scan. And at that point, the application will ask you to pay that 99 cents charge. And after that, you'll be able to have a good face scan to work off of. So at this point, we're ready to show off the software solution that we're currently utilizing and have customized. So Daniel, I'm going to pass the baton over to you.
And while you're doing that, we actually have a couple of quick questions that came through while you were talking there, Josh. So
Yeah, sure.
our friend Fernando out in California wanted to ask, what printer did you use? And I believe that's an Ender 3. Is that right?
Yep, that is correct.
Good
Yeah,
old Ender. Yep.
modifications to it as well too.
And that was for the gold mask that you guys saw earlier, but also some of the other masks. I believe we used, of course, our NextDent 5100 that we have, and then I believe you have a Form 2 there as well that you might have used, right?
Exactly. Yeah. So this material here, this is going to be a silk gold material, and really, I wanted to portray that aesthetic appeal for this.
Yeah.
This is a material called a PLA2, which is actually a lot stronger. And this is printed on my hobby printer as well.
Nice. And then Ulrich wanted to know, which phone are you using? What phone did you have there, Josh?
Yeah, so over here in Virginia, I currently have a Form 2 available for testing. So here's a mask printed off of there. On this, I put some head straps on, as opposed to the ear straps for these other that I printed out.
Looks good.
Yeah.
And then for the face scanning app, which model phone do you have?
Well, I currently have an iPhone XR.
Ah, there you go. Okay.
Mm-hmm.
Beautiful. All right. So yeah, let's Daniel, if you're ready, I think we can move on to that demonstration where we're going to show you exactly how to use the Blender software to custom fit the mask to that face scan that Josh just took.
Okay, so I'm gonna go ahead and share my screen here. See everything. All right. So this is the Blender software. It is, like Josh and Neil said, it is a free software that doesn't need any payment or anything like that. It's something you can download, and we'll probably have a link to it on our website. And when it comes in, it is typically used for like 3D modeling, 3D like animation kind of projects, but it can also be used for what we need now. Since we are going to use a plugin, we are going to have to add it in, so we can do that under Edit and Preferences. And from there, we'll just install the plugin. So we have our My Face Mask Imagine plugin that we're going to install. And once that's installed, we can go ahead and use it. And there are a lot of controls that you can see. This the screen has a lot of different controls, but it is a very simple plugin and you won't have to use the majority of it. All we're gonna do is go to this tiny little arrow over on the side right here and go to the My Face Mask tab. From there, we can go ahead and start a new project, which they call Scene. And then all the tools we'll be using will just be in this small little window right here. So first things first, we should import a scan. Go ahead and select the STL scan. And from here, we'll see we have imported the scan from the Bellows app. It is going to come in oriented any which way, just depending on which scanning process you use. So we are going to have to rotate it a little bit. On the left-hand side over here, there are some controls on kind of moving it. So we will go to rotate. And from here, we can rotate it just 90 degrees to have it follow the face all along the y-axis. Okay. From here, depending on the scan, it can have a lot of meshes, which is like a load of triangles from the STL. It can be messy. So what you can do is you can use a remesh, which will smooth it out just a little bit for their software. And on top of that, if you had some facial hair that got collected by the scan, you do want to smooth that area out because you don't want your mask to be lifted up from any kind of facial hair. So for that, it is a little bit more tricky because we do have to switch it from object mode to sculpt mode. And from here, there will be a smooth option. to kind of smooth out areas. I'm just going to smooth out a little bit so you can see it happening. So you want to kind of flatten and smooth out the facial hair just to keep it like a nice smooth surface for your mask to adhere to. So do that, and we're going to switch it back to object mode. After we've done that, all we have to do is draw the area we would like the mask to appear. So we'll go to define area and start drawing. So I'm just going to left click on the mask or the face and draw the area that the mask will appear in. Come back around the chin and circle back around. And typically, whenever I do this, I always ended up with one side of the face looking different than the other. And that's totally okay, because in the next step, you'll see there's a way to adjust that. It is going to follow kind of the outer areas of the path that you took. So if you need to adjust it, you can just keep adding by left clicking. Or if you go to the subtract, you can remove any areas that you don't want it to follow as well. Okay. After that, we'll go to adapt mask. And already you'll see that the mask is pretty much complete. It's for when I mentioned how one side might look more wider than the other or more thinner than the other, you can do a symmetric order. So if you click on that, it will equalize both sides, and you can kind of pick between the wider one or the thinner one just by clicking invert symmetry. At this point, we do recommend you position the filter area a little better. So we're going to do a line filter here. The line filter will let us kind of control how much space is between the face and the exhale area. And it'll also help because if your printer needs more, doesn't have a lot of area, you want a shorter mask to help it fit on the build platform. So while it's in the move button, you can move it closer or up. You can also rotate the area as well. And you do want to avoid rotating along the x-axis if possible, just because you don't want it to shift to left or right or be tilted one way or the other. Another area to look out for is where the nose might be. If you go too low, you'll see that it'll start touching the nose. So you do want to avoid that because you don't want your nose to be touching on the mask all the way, and you don't want it to also form badly when it's being made. From there, what we're going to do is there's some other controls here. So the nose pressure here will let you tighten pressure along the nose area if we need it. And again, this is just going to depend on face type, but typically we found that keeping it at 0 works pretty much all the time. And it'll just be kind of a as need base. If your printer has more difficulty printing thin areas, then maybe you'd like to play with the thickness. So we can click and drag up to 5 millimeters, or maybe you want to save material and go a little thinner. You can go down pretty thin as well. The masks we made we kept at the default of 1.6 to make sure it works fine. And the last option for the offset is going to be the offset from the face. So again, if we increase it, it'll come away from the face, and we can make it tighter to the face by decreasing it as well. Again, we'll keep it at 1, and that's the default that we found works best for the masks. And lastly, all we have to do is prepare the model. So at this point, what it will do is it will create the attachments for the ear bands or the headbands, whichever one way you want to tie that on. And it'll also create a nice border around the edge of the mask to make sure that you don't have any sharp surfaces that are going to pinch in on your face or cause any irritation there. You can add a tag on it. So you can change this text right here and do insert tag. So this will help if you printing a lot of masks and you need to keep track of what's what. All you have to do is left click on it and it will add it on. Right. So you can add it on. It'll say patient's name or person's name, and you can keep it so that easily identifiable. But after that, it's all set. You can just hit the done button and export it as an STL. So we'll say this is a face mask. And again, so Josh emphasized that feasibility was one of the main factors that we were focusing on when making this, and also like how quickly you can actually make this. So if we kind of start over and just kind of keep all the defaults, you'll notice that everything can be done pretty quickly. I'm just gonna go back into my face mask, import his face again. Around.
And while you're doing this review here, Daniel, we've got a couple of questions that came through, so maybe we can visit those. Donald had a couple actually, and he wanted to know, first off, where can we get the Blender plugin to test? So glad you asked that, Donald. We're going to be posting that on our website in the COVID support section, which if you log on to our main website, imagineusa.com, you'll see a banner up at the very top that points you in the direction of our COVID support section. Everything that you're seeing today, all the links you're going to need for the Blender plugin, for the link to download Blender, all the information that we're talking about is all going to be put up on that section of the website. So keep an eye out for that. If you want it even sooner than that, you just can't wait, shoot us an email at info@imagineusa.com and we'll make sure to get that straight off to you. So that was one thing. The other thing that Donald wanted to know, and Daniel, I don't know if you know this, perhaps Josh, you do. When we tested with the Nextent 5100, which resin did we use? Is that something we know off the top?
Yes, it was actually utilizing the model resin.
Yep, that makes sense. It's definitely one of the more economical resins. So if you're going to be doing a lot of printing, might as well use that.
Yeah, and two key components of that was, you know, I will touch base a slight bit as far as material selections go, in a little bit broader of an aspect, but I mean, it checked off two boxes for our criteria, which was one, we want to make sure it's biocompatible.
Mhm.
So that meaning that, well, this material is actually going to be making contact with your skin for possibly long periods of time. So again, we want to make sure it's safe.
Mhm.
Second is we wanted to make sure that you could sterilize the material itself too, or also kind of defeat the purpose of these masks.
Right. Awesome. Okay. And then actually we had one person correct me here, which I definitely appreciate. That Bellis 3D app actually does require the iPhone X, XS, XS Max, XR, or 11 series to do 3D scanning. So great correction there. Thank you for that. If you want to use that great Bellis app, you do need a certain phone type, iPhone X or 11, in order to use it. So.
So again, while the questions were going, we did just quickly make another mask, the same idea. And from here, we can throw it over to nesting, which Josh is going to go over. Let me switch over to him.
All right. Just want to verify you can see my screen over here.
Yep, everything looks good.
Okay, perfect. So the software that I currently have open is called the 3D Sprint software. If you have a Nextent 5100 printer, this is the software that you're going to be utilizing. Now, before I get into any of the nesting tips, I kind of wanted to go over the features of the mask itself. So first off, there's three components to the mask. One is a washer. One is the actual cap itself. Actually, here. Right, and finally, we have the mask design. I don't know if you can see my mouse properly, but let me get a spotlight option. All right, so again, we got the washer here, we have the cap, and we have the face mask itself. So like I mentioned before, we actually increase the diameter of the opening where the filter is going to be laid out. Now, the main reason for this was to offer breathability, and so you can also exhale properly and no buildup of condensation. Right? Again, we did not introduce the exhale valve, and mainly because it didn't really protect others from yourself if you're a carrier of the virus. So another thing that we wanted to offer was, and it checks off the box for ergonomics, really the comfort and fit, was we actually curved the edges of the perimeter of the mask design itself. And what we were able to achieve was maximum comfort. So I was one of the test guinea pigs for this project as well. So basically, I kept the face mask on for about 8 hours, took it everywhere with me, and I noticed that it was finally comfortable to my face. Part of it was then due to the whole design process, but when I came out with my initial face mask design, it had straight edges, and what it did was it kind of dug into my skin on my face. So it didn't offer the most comfort. So again, we offered these curved edges for more ergonomics and just for overall comfort. Another feature of the mask itself is that, so if you look on the top of the mask here, this is actually your sealing surface to the cap itself. So we have a self-clamping feature where basically from this cap itself, when you're actually twisting it on with the filter in between, filter and washer in between, it'll actually clamp so there's a good overall seal. Now, looking at this cap design here, we also added a mesh grill, and this offers protection for your filter. If there's any blunt force, you may notice that because of the washer, the filter is on very tight. Now, if there's any blunt force to the filter itself, there's a possibility that you can puncture a hole within the filter. So we want to make sure that we added some protection there. Also from the cap design itself, we found out that our logo was actually perfect as kind of a retentive feature, mostly for a grippable surface to remove the cap easily and to twist it onto the face mask itself. Now keep in mind from this washer here, you could actually use this as a guide when cutting out whatever filter that you have available. Now, as far as nesting tips go, now this really depends on what printer you have available. So here, this is based off of the NextM printer and its build platform size. There's really one orientation I could, really orientate this face mask, and it's just really vertically just like this. So some key points with nesting this is, well, first, based on the limitations of your printer, the size of the build platform, you want to make sure it fits perfectly, right? So that's the first step. Next step is you want to make sure that you add enough supports. You don't have to be too conservative as far as the supports go. You can obviously remove in the post-processing stages, but there are certain areas I would try to avoid adding sprues on. And first off, this is going to be one of the most crucial areas. This is your sealing surface from your cap to your filter. And so we want to make sure that we do not add any sprues on the sealing surface here. Now, if you do end up adding some sprues there, it was absolutely necessary. It's not the end of the world, right? You'd want to take certain precautions and make sure that you're able to remove the little nubs left behind from the sprues as much as possible without damaging the contour of the overall sealed area here. So this is one crucial area I would try to minimize the amount of sprues. Now, another area is the sealing surface to the actual face itself, especially this perimeter, because this is going to be making the most contact with your face. Now, again, it's not the end of the world if you do have some nubs kind of left behind. I would try to trim those areas away as much as possible. So first off, it offers the best seal possible. Second, to increase the amount of comfort. Now, I'm looking at this view here, you can see that with this cap, I actually orientated this with an incline of about 20 degrees. And this rule really applies depending on the printer that you have. Some may be more sensitive than others, but even if I have a flat object, I like to provide an incline of about 20 degrees. And the reason is it builds up with less adhesive forces. So maybe even for dental applications, maybe you've noticed that a lot of your models are dropping off. They're falling into the resin container during the print process. It's because that when the build platform is basically creating a layer, it moves up. And during the point of time when it actually moves up before going back down and printing off that next layer, there's some adhesive forces, basically a suctioning effect that's occurring. So with less surface area facing towards the resin, you can avoid a lot more drop-offs with the parts itself. So again, I would provide about a 10 to 20 degree incline. One worry with this mask initially was, well, we have external threads here. There's no real way of getting around getting sprues on the threads itself. So what we did was we actually increased the tolerance a bit with our cap design, where basically it fits in a little bit looser, but part of it was so that we can take that perfect average based on whatever printer that you're using and make sure that these caps will fit on perfectly every time. Now, you want to do your due diligence if you have sprues on the threads itself, where you trim off and contour it up as best as possible. But again, if there's a little bit of material kind of left behind, you still will be able to utilize your cap and twist it on properly with a good seal at the end of the day. Now, other than that, I kind of want to show off the orientation that I provided with the Formlab software. So this is what I have on screen here. I have a lot more space to kind of work with when it comes to the Formlabs printer, but I still orientated it in a vertical direction like so. First reason why is because I wanted to make sure I did not get any sprues on the sealing surface here. And I wanted to minimize the amount of sprues on my sealing surface to the face. Again, once everything's printed, you want to make sure that in the post-processing stages, prior to light curing, you contour. I actually just used a knife to really smooth out some of these areas where I didn't want the nubs from the sprues to be. It was quite easy to do, but from the preform software, this is exactly what I proceeded with. I also have my, for my home printer, this is the software that I'm currently utilizing. It's something called Ultimaker Cura. As mentioned before, it's about a $200 printer. It uses filament. I actually have a larger build plate for this printer. So I was able to print out all three components all at the same time. One thing I did, which maybe a lot of people may not do, is add something called a raft. So yeah, you are wasting a little bit more material, and it does bump up the time quite a bit. But when you're actually utilizing this filament, it's very cheap, and they come in spools. So if you look down here, basically the calculation for how much filament I used, it costed me about $2.52. It's not bad at all. Most generally, I would actually print this mask vertically, but just for time's sake, I actually printed it out horizontally. What this kind of affected by printing it out like this was it added supports to the inside and the bottom of the mask itself, especially on the border of the mask. So after printing it out and putting it on my face, it wasn't the most comfortable. But again, for demonstration purposes, I laid it out horizontally. Okay, so I'm gonna go ahead and stop sharing at this point. Start my video back on again. So you'll probably have some questions as far as filter selections. Now, First off, where a lot of these filters weren't easily accessible, like the P100 filters, the Roomba filters. So when we did our research, we were able to find that there's a MERV RV 13 filter available. This you can actually buy in sheets. It's about 24 by 36 that I'm going to show you here.
Could you say that name again there, Josh? I think the audio cut out real quick and you said the name of the filter.
Oh, I'm sorry?
Could you say the name of the filter one more time?
Yes. So it's called a MERV 13. That's a MERV 13.
Perfect.
And again, this comes in a 24 by 36 sheet. So that'll actually last you quite a bit of time. It's still available off of Amazon, which is where we purchased it from. So this was about $16, not bad in price. Now, the MERV 13, it provides about 89% particle filtration from what we've researched so far. The different MERV ratings, it actually goes way higher than MERV 13. But if you want to get a little bit closer to about, like the N95 masks with 95% particle filtration, you'll want to go with something called a MERV 16. It's just that it's not the most accessible. So do keep in mind that with the MERV 13, you can actually create layers with this filter. So if you take about 6 sheets of this filter, that'll actually get you to that 95% filtration. If you have about 3 plies of this filter within your mask, it can offer about, say, 92% filtration. Now, I touched base as far as the materials a bit before. Now, you want to do your due diligence and make sure you do the research to see what materials are available for your printer and does it check the boxes of biocompatibility, and also can it be sterilized. So it's kind of hard for me to say, based on the materials available for your printer, which ones are going to be able to offer, but at least keep those 2 points in mind when making your material selections. At least for my hobby printer at home, I was able to find that there is a material called a PETG. And with this material, it checked off the 2 boxes from the slight research I've done so far that it is biocompatible and you're able to provide a sterilization for it. So other than that, that concludes our presentation here. So I think we're ready for questions.
Which, looking at our the Q&A line here, I think we've answered all of them. We haven't had a lot of them come through, which I think you've been doing a very thorough design. So we've got one person asking, can we have another look at the final design? And actually how you load the filter on into it there. So maybe kind of demonstrate, Josh, the final design and equipping the filter onto it.
Yeah, sure. So, I guess first, here's my final face mask design. I'll actually put it on real quick too. And with this one, I actually put on some ear straps. Obviously, with the straps that you have available, you can do a head strap, which may be more comfortable for long periods of use. Let me go ahead and take this off here. So I'm gonna go ahead and unscrew the cap. We have our washer in between here. The filter itself, I used the washer as a guide to be able to cut out this filter here. So first off, I'm gonna take this filter, I'm gonna drop it in to the inside of the cap here. Okay. And you do want to make sure it stays as flat as possible. Now, in case that you actually overcut the filter, let me see. Inside here, there's actually a little offset so that your filter can still slip in between. So after I have the filter on, I'm going to drop the washer in, and that'll offer a better seal than using the cap without the washer. Other than that, that's about it.
Pretty straightforward.
Yep. Everything that we wanted to go ahead and do for this whole mask project was make sure that every process was simplified to its maximum degree.
Beautiful. Well, let's see here. I think that's just about it. So we're going to keep an eye on the Q&A line here and see if there's any other questions coming through. Oh, actually, we've got one here. Can we layer filters in the mask? I think the answer is yes. And how many layers does it take to increase it up to roughly an N95 filtration, Josh?
About 6.
About 6 layers.
I mean, there was a point where we could actually reduce the size of this cap. And the reason why we didn't was, well, if you want, you know, maximum filtration and you have, say, the MERV 13 available, why not stack the filters?
Yeah. Is there a maximum number of filters that you can fit in there? I bet you can probably fit quite a few.
In this mask, I actually have 3 filters in here, and this fits comfortably.
Yeah.
I would say that 6 should be no problem.
Okay. Perfect. So again, we'll keep